Hey, algebra students. In this video, we're going to be talking about solving systems of equations. A system of equation is when you have two different equations. They have different different coefficients on the variables, even though they actually have the same variables. So notice I have x and y in this equation, x and y in this equation, but they're different equations. Okay, and that is a system of linear equations. A solution to a system of linear equations is an ordered pair that solves both equations at the same time. Sometimes systems of equations will have a solution and sometimes they will not have a solution. And we'll talk about that in just a little bit. But actually, in this case, we're looking at linear equations that have a solution, and we're wondering if the ordered pair that we're using is a solution. Okay, so we're going to be looking at that. And then what we're going to do is we're going to actually graph these equations. I'm going to graph them in GeoGebra. Most of the time, you're going to graph them on graph paper. I'm going to show you the one exception where you're allowed to use GeoGebra to graph your equations as well. And I'm going to show you how, when you graph these equations, you can figure out what the solution to the system of equations is. All right, so let's dive into the practice. And I see at the beginning of the practice here, it asks to tell whether this ordered pair is a solution to the system of equations. How do we do that? Well, we just plug in the numbers. So this is an XY coordinate pair. The first value is an X value, the second value is a Y value. Let's see if both of these equations are solved by the pair 1, 3. 2 times 1 is 2, plus 3 is 5. 2 times 1 is 2, plus 6 is 8. Yes. So letter A, the answer is yes, the ordered pair is a solution. It works to solve both equations. Let's try the second one. So we're going to plug in 3, 4. 2 times 3 is 6, plus 4 is 10. Ooh, it didn't work for that one. 2 times 3 is 6, plus 8 is 14. Didn't work for that one. 3, 4 is not a solution for either of these two equations, and definitely not for both of them. So we're going to say no. Now, it doesn't. If it was a solution for one equation and not the other, we would also say no, it is not a solution for the given system. But 3, 4 didn't solve either of these. So what we would find if we graphed these two lines, the point 3, 4 wouldn't be on either of them. If we graphed this first line, we'd find that the point 1, 3 is on that line. If we graph the second line, we see that the point 1, 3 is on this line, and we see these two lines cross at point 1, 3, and that's the solution. All right, letter C. Solve the system by graphing, then check your solution. So here's how we're going to use GeoGebra to graph these, because I'm showing this on a computer and it's hard for me to graph things on the computer without using a program to do it. You would be expected for letters C and D to graph using graph paper, and then you would see if you can find the solution using graph paper. For letter E, because there's a little picture of a graphing calculator here, you'd be allowed to use a graphing calculator for that one, but not for C and D. Okay, anytime there's that little picture of a graphing calculator, it says use a graphing calculator to solve. It's okay for you to use GeoGebra or a graphing calculator to solve that problem. Let's take a look at some of these. Y equals 2x minus 5. So I'm going to go to GeoGebra. We're going to start calculator, and we're going to delete any old stuff I have in here, and we're just going to type in that exact equation. Y equals 2x minus 5. There is that graph. 2x minus 5, y equals x minus 3. Y equals x minus 3. Notice that these two lines cross at a point. That point is going to be the xy coordinate that solves both. There's a lot of other points on this line, right? I can click anywhere on this line and find an XY coordinate that solves just this line. And I can click anywhere on this line and find an XY coordinate that solves just this line, just this equation. But where they cross, that's a solution to both equations. I can click on it in GeoGebra and see that the solution to both is 2, negative 1. Hey, let's try that out. So I'm going to plug in 2 for x. 2 times 2 is 4. Minus 5. Let's see, 2 times 2 is 4, minus 5 is -1. That's a solution to that one. 2, -1. Let's try the second one. 2 minus 3 is -1. All right, that works as a solution. Let's try D. Y equals 2x minus 5. Oh, the first equation is the same. The second one is 3x plus y equals 15. Okay, so we're going to enter that as the second equation. So 3x plus y equals 15. Okay, they cross here. The point is 4, 3. So I'm going to type the ordered pair 4, 3 as our answer. Let's see if both are solved. 2 times 4 is 8, minus 5 is 3. 4, 3 works. And then let's see. I'm going to plug in 4 for x and 3 for y. 3 times 4 is 12 plus 3 equals 15. Solves both equations. That's a good ordered pair. All right, now let's do the next one, the one that actually calls for a graphing calculator. 2x plus 3y equals 6. We're going to get rid of both of our equations here. And then we're going to do 2x plus 3y equals 6. Okay, there's that line. And then our next one is y equals x minus 12. Y equals x minus 12. Oof, we're all the way down here. And this one is 8.4 negative 3.6. I'm going to plug, let's see, 8.4 negative 3.6. Now, if I were to plug that into these equations, it would solve both of them. 8.4 equals negative 3.6 minus 12. Let me think about that for a second. Oh, no. Okay, so when I plug this in, I have to make sure I plug in the right thing for x and y, right? X is 8.4. 8.4 minus 12 is negative 3.6. I could plug that into a calculator to double check, but that seems plausible. And then 2 times 8.4, that's going to be somewhere around like 17, plus 3 times negative 3.6. That's going to be somewhere a little bit greater than like 10. So it's like 17 minus 10 is going to be about 6. Yeah, it seems plausible too. So I didn't check my solution in a calculator. If I plug these numbers into a calculator, though, they should come out exact. I just did to make sure that they were plausible, and they definitely are. All right, now letter F. Jill has $20 in her savings account and plans to deposit $5 each week, 5 times the number of weeks. That's going to give me the total amount in her savings account. Jose has $5 in his account and plans to deposit $10 each week. After how many weeks will they have the same amount of money in their accounts? What is that amount? All right, well, I can plug both of these. 20 plus 5w equals t. Y equals 20 plus 5x. There we go. And then my other equation, y equals 5 plus 10x. I thought that GeoGebra would allow me to use anything for my variables, but apparently it's restrictive. Okay, now I'm way off the graph here, so I need to zoom out, zoom out, zoom out. There. They cross, so at 3 weeks, they both have $35 in their account. So 3 weeks is the amount of time, and then $35 is the amount of money that they have in their accounts. That's what the intersection of this graph tells me. All right, you are now ready to do numbers 1 through 30. Make sure you are using actual graph paper unless told to use a graphing calculator. I do expect to see graphs made for any of the graphing questions in this lesson.